तो हेलो एवरीवन। अभी अपने कर रहे थे कार्बन कोऑर्डिनेशन कंपाउंड्स। आज जो टॉपिक है हमारा दैट इज बॉन्डिंग इन मेटल कार्बोनिल्स। अब देखो, मेटल कार्बोनिल में जो बॉन्ड बनता है, पहले तो सबसे पहले क्या होता है कि मेटल का जो वेकेंट ऑर्बिटल है, ठीक है, मेटल का वेकेंट ऑर्बिटल और जो सीओ है, कार्बन मोनोऑक्साइड, उसका पाई टू पी ऑर्बिटल, फिल्ड पाई टू पी ऑर्बिटल, किसका? सीओ का। कार्बन की तरफ से वो क्या करता है, मेटल के वेकेंट डी ऑर्बिटल के साथ बॉन्ड बना लेता है। कौन सा बॉन्ड बनेगा? ये सिग्मा बॉन्ड, वीक सिग्मा बॉन्ड बनेगा। ठीक है, तो क्या हुआ, फर्स्ट स्टेप में जो मेटल है उस वेकेंट डी ऑर्बिटल और जो सीओ है उसका फिल्ड पाई टू पी ऑर्बिटल, दे ओवरलैप बाय सिग्मा बॉन्ड, और इस तरह से सीओ क्या हो गया, इलेक्ट्रॉन डोनर, that behave as a weak base, or we can say weak electron donor। तो ये फर्स्ट जो है टाइम जब सीओ इंटरेक्ट करता है मेटल के साथ, तो एक सिग्मा बॉन्ड बनता है सबसे पहले। उसके बाद क्या होता है, अगर ये सिर्फ एक सिग्मा बॉन्ड बनना होता तो सीओ शुड बी अ वीक लिगेंड, और वो डेल्टा ओ जो है ना उसको लार्ज नहीं करता। बट होता क्या है एक्चुअल में कि once this sigma bond is formed, then metal filled orbital of metal, after the formation of this sigma bond between carbon of the carbon monoxide and metal, vacant pi star anti-bonding orbital, vacant pi star anti-bonding molecular orbital of CO that overlap with filled d orbital of the metal. So in this way, metal back donate its electron to the CO, and that's why in this way CO is accepting the electron and leads to the formation of pi bond, strong pi bond. So CO is pi acceptor ligand. Now this already formed sigma bond that gives strength to the pi bond and vice versa. So this type of bonding is known as synergic bonding, because both are working toward the same goal. Formation of metal carbon bond takes place, and in this way there is the double bond character between metal and carbon, and CO bond strength decreases. CO bond strength decreases and metal carbon bond strength increases. Okay, and this type of synergic bonding leads to the double bond character between metal and carbon, and because of this, delta O increases, and that's why CO is in the extreme end of the right end of the spectrochemical series because of synergic bonding, because CO is a pi electron acceptor ligand. Synergic bonding, did you understand this? What is synergic bonding? Synergic bonding means providing strength to the already formed bond. Sigma bond formed is weak, but when pi bond is formed, that provides strength to the sigma bond, and sigma bond provides strength to the pi bond, and vice versa, means they are increasing each other's strength, and that is called synergic bonding. And if we have nickel carbonyl bond like NiCO4, so NiCO4 is tetrahedral, FeCO5, this one is tetrahedral, FeCO5, it is trigonal, bipyramidal, then CrCO6, it is octahedral. Now Mn2CO10. In Mn2CO10, structure is like this. There is a single bond between two Mn, and 5CO is attached like this. Okay. The bond with the CO, they are coordinate bonds, coordinate covalent bonds, and between M and Mn there is a simple covalent bond. One electron from each manganese are involved in bonding. CO2, CO8. Yes, beta. CO2, CO8. What about the structure? CO2, CO8. So see, in CO2, CO8, there are two types. Three CO on each cobalt are like this, and remaining two they are like this, or it can be written as these are the structure: NiCO4, FeCO5, CrCO6, CO2, CO8, and Mn2CO10. So they keep in mind these structures as well. Okay. तो ये हो गया about metal carbonyl. और हमें करना है yes, stability of coordination compounds. Now, when we talk about stability of the coordination compounds, if we have a coordination compound with coordination number 6, so it is Ml6. So this beta 6 is equal to concentration of Ml6 divided by concentration of metal, concentration of ligand raised to power 6, and this is called overall stability constant. And higher the value of stability constant, more is the stability of the complex. Now, in terms of stepwise stability constant, first, metal attached to first ligand, we get Ml, and this is first stability constant, and that is concentration of Ml over concentration of metal into concentration of ligand. Then Ml plus L, it is Ml2. So K2 is equal to Ml2 divided by Ml concentration into L concentration. Second stability constant, then Ml2 plus L, it is Ml3, K3 equal to Ml3 over Ml2 into L, Ml3 plus L, so it is Ml4, so K4 equal to Ml4 Ml3 into L. Then Ml4 plus L gives Ml5, so K5 is equal to Ml5 concentration, Ml4 concentration into L concentration, and last ligand, so it becomes Ml6. So K6 is equal to Ml6 over Ml5 into L. So this K1, K2, K3, K4, K5, K6, K1, K2, K3, K4, K5 and K6 are stepwise stability constants. Now this beta 6, that is overall stability constant, is equal to product of these stepwise stability constants. So overall stability constant is equal to product of the stepwise stability constants. Okay. Now instability constant or dissociation constant, that is equal to 1 upon beta 6, 1 upon stability constant, that is called instability constant or dissociation constant. So higher is the value of stability constant, lower is the value of dissociation constant. Okay, so we can say higher is the value of overall stability constant, or it is also known as formation constant. Higher is the value of overall stability constant or formation constant, greater is the stability of the complex, right? Greater is the stability of the complex. So this is about the stability of coordination compounds. Now next, factors affecting stability. Factors affecting the stability of the complexes. So first factor is charge on the central metal ion. Charge on the central metal ion. Keep in mind, higher is the charge on the central metal ion, more is the attraction of the central metal ion with the ligand, and higher is the stability of the complex. Okay, so you can write greater the charge on the central metal ion, greater is the stability of the complex. Okay, now second factor. Second factor is basic nature of the ligand. Sorry, nature of the metal ion. Nature of the metal ion. तो metal ion जो है they are grouped into two classes. ठीक है, तो पहला है क्लास ए एक्सेप्टर्स, क्योंकि मेटल जो होगी वो लिगेंड से इलेक्ट्रॉन को एक्सेप्ट करेगी ना, ठीक है, तो दे आर एक्चुअली लुईस एसिड्स, ठीक है, तो पहला है मेटल ए एक्सेप्टर्स, ठीक है। तो ए एक्सेप्टर जो है वो कौन कौन से हैं, मतलब ग्रुप 1 और 2, ठीक है। और अर्लियर मेंबर्स ऑफ द ट्रांजिशन मेटल्स ग्रुप 3 to 6 और इनर ट्रांजिशन एलिमेंट्स, इनको हम लेते हैं ग्रुप ए एक्सेप्टर्स। मेटल ए मतलब क्लास ए बोल सकते हैं ना। और इनर ट्रांजिशन एलिमेंट्स, तो ये जो है दे फॉर्म complexes or we can say stable complexes कब, when donor atoms जो हैं of the ligands are nitrogen, oxygen और फ्लोरीन, ठीक है। तो याद रखना कि क्लास ए एक्सेप्टर्स, क्लास ए एक्सेप्टर जो है कौन कौन से हैं, ग्रुप 1 and 2 मेटल्स, ठीक है। और अर्लियर मेंबर्स ऑफ द ट्रांजिशन सीरीज दैट इज ग्रुप 3 to 6, है ना। और इनर ट्रांजिशन सीरीज, तो इन केसेस में कब स्टेबल कॉम्प्लेक्स बनेंगे, जब जो लिगेंड है उसमें जो डोनर एटम है वो या नाइट्रोजन हो या ऑक्सीजन हो या फ्लोरीन, ठीक है। नाउ सेकंड, क्लास बी एक्सेप्टर्स। क्लास बी एक्सेप्टर कौन से होते हैं, ट्रांजिशन मेटल्स, ट्रांजिशन एलिमेंट्स आफ्टर ग्रुप 6, 3 to 6 तो ग्रुप ए में आ गए, है ना, क्लास ए में आ गए, क्लास बी में आफ्टर ग्रुप 6, है ना, जिनमें आई एम फैंटास्टिक बेटा, केमिस्ट्री लवर, वाह, हैव रिलेटिवली फिल्ड डी ऑर्बिटल्स, जैसे हो गया रोडियम हो गया, प्लेडियम हो गया, सिल्वर हो गया, गोल्ड हो गया, मरकुरी हो गया, ये सारे, ठीक है ना। तो ये जो है दे फॉर्म स्टेबल कॉम्प्लेक्सेस कब, व्हेन डोनर एटम्स जो हैं लिगेंड्स के, दे आर हैवियर मेंबर्स ऑफ नाइट्रोजन, ऑक्सीजन एंड फ्लोरीन फैमिली। तो देखो, आपने मेटल आयन के नेचर के बेस पे भी स्टेबिलिटी देख ली कि उसमें क्या देखा जाता है कि अगर क्लास ए एक्सेप्टर्स है, क्लास ए एक्सेप्टर में कौन कौन से हैं, ग्रुप 1 and 2, ट्रांजिशन एलिमेंट्स में ग्रुप 3 to 6 और इनर ट्रांजिशन एलिमेंट्स। तो ये अगर है तो कॉम्प्लेक्स स्टेबल कब बनाएगा वो मेटल, जब डोनर एटम नाइट्रोजन, ऑक्सीजन या फ्लोरीन हो। दूसरा, क्लास बी एक्सेप्टर्स हो अगर, कौन होते हैं वो, ट्रांजिशन एलिमेंट्स आफ्टर ग्रुप 6, तो दे फॉर्म स्टेबल कॉम्प्लेक्सेस कब, व्हेन जो डोनर एटम है दैट इज हैवियर मेंबर्स ऑफ नाइट्रोजन, ऑक्सीजन एंड फ्लोरीन फैमिली, जिनमें रिलेटिवली फिल्ड डी ऑर्बिटल होता है, ठीक है। नाउ सेकंड कैटेगरी, थर्ड पॉस्टुल, मतलब factor which affect the stability of the complex, that is basic nature of the ligand. तो लिगेंड का बेसिक नेचर, तो जितना बेसिक होगा लिगेंड उतना ही कॉम्प्लेक्स की स्टेबिलिटी ज्यादा होगी, क्योंकि उतना अच्छा डोनर होगा ना वो, उतना अच्छा क्या हो जाएगा वो डोनर. तो greater is the basic strength. Okay, 1 second I will explain it. So greater is the basic strength of the ligand greater is the stability of the complex. Actually, like say we have ammonia. Now ammonia in itself it is a stable, but at the same time nitrogen has a lone pair, so it can share its electron pair with other element which can uh, gain, and after gaining those electrons it feels satisfied. Now um, metals have vacant d orbitals, metals have vacant orbitals, and if they accept electron in those orbitals they get satisfied in terms of their orbitals, because they have vacant orbitals, and in those vacant orbitals if electrons are filled they form a stable entity, stable compound, stable complex. That's why metals have tendency to accept electron pair. Okay, otherwise metal has tendency to lose electrons, that everybody knows. Okay, but when someone is there to donate, then metal has the ability to accept if it has vacant orbitals, because after forming bond energy is released, and whenever energy is released stability comes, and at the cost of stability everything happens. See, everything combined, everyone combined with each other to attain stability. Same is the case with metal. Ranjit Singh, only 5 is watching. That doesn't matter. What matter is how effectively they are watching. Okay. I'm not interested in numbers. Okay. Next is presence of chelate rings. So what are chelate ligands or chelate rings? So actually formation of chelate rings. What are chelate rings? 5 or 6 member rings formed by di or polydentate ligands that I draw once I complete this sentence. Formation of chelate rings increases the stability of the complex. Now this stabilization due to chelation Stabilization due to chelation is called chelate effect. Is called chelate effect, and it is found to be maximum in for the 5 and 6 membered rings. For example, we have CO, En thrice 3 positive. So En is a chelating ligand. How do we know? Because En is NH2, CH2, CH2, NH2. Okay, I'll let you know. Don't worry. Okay, Dhananjay Singh, thank you. See, CO, it is NH2, CH2, CH2, NH2. Okay, same here, NH2, CH2, CH2, NH2. So see, cobalt 1, NH2, 2, 3, 4, 5. These are the 5 membered rings. As these 5 membered rings are formed, this is called, these are the chelate rings, and more is the number of chelate rings, more is the stability of the complex. Okay, so if we compare it with NH36, then COEN thrice 3 positive is more stable than CONH36 3 plus. Okay, now come to the thermodynamics part. Actually, what would happen? You know, when we have CO, teacher asked me that how entropy is affected by chelation, and I think it decreases. But he said entropy increases by chelation, and that's why it increases stability. Okay, see, we have COEN thrice 3 plus. Okay, if it dissociate, it will give like this. These are the product of dissociation. Okay, now come to CO NH36 3 plus. See, whenever chelation takes place, obviously there is a decrease in entropy. Okay, but when you look at these two structures, this is the complex of chelation, chelating ligand. Yes, Dhananjay from 8 to 9. CONH36 3 plus. Here delta S is positive. In this case, delta S is positive. But here it is more positive, and in this case, it is less positive. Got my point? In first case, delta S positive has less value. In second case, delta S positive has more value. That means dissociation of complex with monodentate ligand is more favorable. Means we can explain it in this way. Okay, but as delta S is, see, delta G equal to delta H minus T delta S, delta H is almost same. Delta H is almost same. But if we talk about delta S, I'm talking about dissociation. Okay. So in dissociation, delta S is more positive in this case. In case of monodentate ligand. And that's why delta G is here, delta G is more negative. In this case, delta G is less negative. Got it? Yes, beta. We can explain it in this way. Undoubtedly, whenever ligands are attached to the metal ion, entropy is going to be decreased. But when this dissociation takes place, then that makes a difference. Or if you talk in terms of formation, so if we in terms of dissociation, you can go like that. In aqueous solution, the formation, then you can go like this. Okay, and in this, okay, so whenever chelation takes place, because ligands are less and more ligand as a water goes out, so you mean to say it is like this, right? Entropy, yes, entropy will be more. Say if we are talking in aqueous solution, already metal ion is in the complex form, but weak ligands are attached, that is water. So water goes into the solution, okay, and 3 En that gets attached and 6 water are in the solution. So means number of moles, number of molecules will increase in the overall solution, right? Okay, the entropy will be more positive in case of chelation, and in this case it remains as such, okay, because 6 ammonia molecules are gets attached and water molecules are in the solution, same number of water molecules in the solution. Okay, so next is effect of multidentate fifth one is okay, effect of इफेक्ट ऑफ मल्टीडेंटेड साइक्लिक लिगेंड्स। तो अगर लिगेंड जो है वो मल्टीडेंटेड हो और साइक्लिक हो, ठीक है, विदाउट एनी स्टेरिक हिंड्रेंस, स्टेरिक इफेक्ट नहीं होना चाहिए, साइज के कारण जो हिंड्रेंस है वो ना हो, तो स्टेबिलिटी ऑफ द कॉम्प्लेक्स इज फर्दर इंक्रीज्ड, दैट इज कॉल्ड मैक्रोसाइक्लिक इफेक्ट। ओके यार, तो मल्टी डेंटेड लिगेंड्स की बात करें, अगर इफ द लिगेंड happens to be multi dented and at the same time cyclic, multi dented and cyclic, तो क्या होगा, without steric effect, then stability of the जो complex है is further increased and effect is called, क्या बोलते हैं इस इफेक्ट को, मैक्रोसाइक्लिक इफेक्ट। Okay, so these are the effects which increase the stability of the complex. Now this one, charge on the central metal ion. So if charge on the central metal ion is same, like 3D series, manganese, iron, cobalt, nickel, even copper, then what is the order of stability? Yes beta, बोलो। अगर चार्ज ऑन द कॉम्प्लेक्स सेम हो, मेटल आयन पे सेम चार्ज हो, मैं बात कर रहा हूं मैग्नीज टू आयरन, कोबाल्ट, निकल, कॉपर और जिंक, तो क्या ऑर्डर हो? अच्छा, इसका मतलब पहले तो चार्ज की बात हो रही थी कि ट्राइवेलेंट कॉम्प्लेक्सेस मोर स्टेबल होंगे डाइवेलेंट आयन से, है ना। अब मैं बोल रहा हूं कि इस ऑर्डर को बोलते हैं इरविंग विलियम्स ऑर्डर, ठीक है। तो स्टेबिलिटी जो है फर्स्ट टाइम सीरीज की, वो बेटा इंक्रीज करती जाती है, याद रखना ही। इट गोज ऑन इंक्रीजिंग as atomic number increases. So that's all for the day. Thank you so much, और अच्छे से इंटरेक्ट किया सबने। ठीक है बेटा, बाय।